Hi grade 12s. What we've done so far in financial maths is topic 1 was just a brief look at grade 11, and topic 2 and 3 were the two different annuities and the formulas and how they work and a couple of questions. And now topic 4 is the idea of balance of a loan and the final payment, which involves both of those annuities. Now this is a really important kind of section simply because you have to be able to work out how much money you still owe on a loan. That is going to be a really important thing in life. And a lot of the time in terms of final payment, we've been talking about, she'll make 42 payments and then a smaller payment. So what is that smaller payment? How do you work out what the last payment is on your loan? So we're going to do this through 3 examples. Example 1 says a car is bought for 180,000 Rand, 10% is paid as a deposit, and the balance is taken out as a loan to be repaid over 6 years. So monthly installments, I'm saying that word. So immediately this is an annuity, and because it's a loan, the lump sum is in the present, so it's a present value annuity. So it says determine the monthly installments. Well, first of all, there was a deposit, which was 10% of 180,000. So that's just a little bit of an extra hoop to jump through. So you could just times this by 90% to figure out the loan, or you could find out what the deposit was, and therefore the loan is 180,000. Take away this deposit. So that means my loan is 162,000 Rand. And now it says, can we find our monthly installments? So this should be fairly kind of routine for us now. So 162,000 Rand is my loan. I don't know my X. This is a present value annuity, so 1 minus 10.5% compounded monthly, and it said 6 years, so that will be 6 times 12, which is 72 monthly installments, all divided by my interest rate. And now personally I wouldn't show any working. I would jump straight to what X equals, and it's because I work out this, and that's the coefficient of X, and then I just divide by it on both sides, and I get an installment value of 3,042 Rand and 19 cents that you would have to pay off every month for 6 years. Okay, great. Now determine the balance of the loan immediately after the 24th payment. Now that's really important. The way we're always going to work out the balance of the loan works it out immediately you make a payment. Now, why would you want to find out balance of the loan? Okay, well, what happens if you won the lottery and you now want to pay off your loan? So you want to know how much I owe so I can pay it off in one lump sum. Maybe, for example, you've come across tough times and therefore you can not make the next payment. So you need to know how much money you have now so that you can skip a couple of payments and start again when money is more freely flowing. So there's lots of reasons why in life you'd want to find out the balance of your loan. So most importantly, we find the balance immediately after, and this question says our 24th payment. Okay, now there are probably 5 ways to do this question. There are 2 most common ways, and I call them the future value annuity way, and then there's the present value annuity way. Now, I always do future value annuity simply because it's always accurate and you can always do it. The present value annuity way isn't always 100% accurate, and also, for example, in this question, I wouldn't actually be able to do the present value annuity way without doing a whole bunch of other calculations. And so I'm only going to show you one way, which is the future value annuity method. Okay, now this method works on the following premise. We had a loan of 162,000 Rand in the present, and we're making 72 payments of X, and so every month I'm adding interest to that 162,000 and then subtracting my 3,000 Rand payment, and then adding interest and then subtracting another 3,000 Rand payment. Now they want to know what the loan is at 24 months. So immediately after I paid my 24th payment. So there would be one payment at the end of month 1, the end of month 2, end of month 3, and so on until you've made 24 payments. Now this method works on the idea of 2 steps. The first step is, let's pretend our loan of 162,000 Rand is not paid off at all. What would that loan be at this 24th time period? Because that's where I'm interested in. What would my loan be if I hadn't paid off a single cent? So that's my first step. I'm just going to write that in. What would the loan be at, now in this case it's time period 24, but it could be anywhere, if not a single payment was made. Now if a single payment wasn't made, what would 162,000 Rand be doing this whole time? It would be gaining interest. So all I'm going to do is find out what is 162,000 Rand and all that interest that it would have gained if I hadn't paid off a single cent. So what would the loan be worth if not a single payment is made? Basically, I just need to add interest. Now, if I'm just adding interest to a lump sum, that is a compound interest formula, which is P 1 plus I to the power of N. So I'm going to take my 162,000 Rand. I'm going to pretend not a single cent was paid off. It was 10.5% interest compounded monthly, and I'm going to move it to the 24th month. And I get a loan amount then of 199,673 Rand and 30. Well, I'm not going to round off. I'm going to keep them all because this isn't the answer to my question. So that's the first step. Pretend that the loan was not paid off at all. What would my loan have been? Okay, now what's my second step, which I'm going to do on this side of the page? My second step is, but hang on, wait just one moment. You made a lot of payments. In fact, you made 24 payments. You made, and I'm going to call them X because I don't feel like writing 3,000 as all the senses, but I made 24 payments at various times. Now, the most important thing in financial maths is to remember that you can only add and subtract money if you find out what it's worth at the same time. So I have found out what my loan is worth at time period 24. Can't I figure out what all these payments are all worth at time period 24? Because then I can say, well, here's my loan and here's all the value of my payments. I can subtract. I can say, here's the value of my loan, here's the value of my payments. Let me take the payments away from what I owed. So what we're going to do here is we're going to say, right, what is this payment worth at the end? And this payment worth at the end, and this payment worth there, and all these other X's that happen in between, and this last X. What are all of those 24 payments worth at time period 24? Now that's a future value annuity. So even though this is a loan, I'm actually going to use a future value annuity to find the value of all the payments in the future. So I'm going to write that as my note for my second point. I want to know how much are all the payments worth together. So I want to add them up, which is why it's an annuity, because you're adding them all together. So how much are all the payments worth together at time period 24? And that is a future value annuity. So I'm going to use my future value annuity formula, which says that my X, which is 3,042 Rand and 19 cents. Now, why am I using a rounded off version there? Is because when you pay, you can only pay cents. You can't pay fractions of cents. And so you would actually pay 3,042 Rand and 19 cents, even though that's rounded off. And this is now 1 plus 10.5% compounded monthly. You're making 24 payments. Now, can you see why this question has to say on the day you make your last payment? Because this formula works out what payments are on the day you make that 24th payment. And so that's why the question stipulated that immediately after the 24th payment. Okay, I'm going to work that out. And I get that the value of all those payments is 80,850 Rand. And now I'm going to keep all of these cents because I still have to subtract. Now, of course, if I get something bigger than 199,000, I've done something wrong because my loan wasn't paid off by this time, so I can't have negative money owing. And so now my third step is to just say, that's great. I'm going to take what my loan is worth at this time, subtract what my payments are worth at that time. And so basically that means that amount, subtract that amount with all those wonderful decimals. Try to use the answer button on your calculator a lot, and I get 118,820, and I'm going to round off now, which is 7 cents. Okay, now again, this is one of the methods. I always prefer this method. It does take slightly longer than the present value annuity method. However, in this particular question, with the information they gave you, you would have to do so much more working on that method. So every question has pros and cons to each method. So let me just discuss this again. So my first step is to pretend that you didn't make a single payment and find out what a 162,000 Rand loan would be worth after 24 months if you didn't make a payment. Then you actually did make payments. You made 24 payments. So what are the value of all of those payments together at the end of 24 months, which is a future value annuity? And then you subtract the two. So that is my loan balance immediately at 24 months. Okay, now lots of people get confused with this because they're like, but why would you add interest onto 162,000 Rand if you didn't owe it the whole time? And so it's a bit of a mathematical trick here in that I've added interest onto 162,000 Rand the whole time. But what I've also done is I've added interest onto all these X's. And so all the interest that I'm adding onto all these X's, that's the interest that those X's, by paying them when I paid them, they saved me that interest. And so that's why I take away those X's and all the interest that they saved me in a way. So this is not how the real world works, but mathematically this works out. Okay, let's look at the next question. This question is an interesting one. How much interest has been paid over the first 24 months of repayments? So let's just think about this for a second. Her loan was 162,000, and if she added interest the whole time up until 24 months, she then owed 199,000 Rand. But the reality is, you didn't actually owe that because you paid X's along the way. So how much money was interest? Okay, well, let's have a look at how much you physically paid. You would have physically paid 3,042 Rand and 19 cents 24 times. So that's physically what you would have given to the bank. So that means 73,012 Rand and 56 cents was paid for this. I can't remember, was it a car? Let's see. It was a car. So you have physically paid over 73,012 Rand and 56 cents for this car. Now, what was the loan originally? The loan originally was 162,000 Rand originally. Now, we've just worked out the loan now. So what is my balance now? My balance now is 118,820 Rand and 7 cents at 24 months. So how much money have you actually paid off? So if my loan was 162,000 and now my loan is 118,000 Rand, how much effectively have you paid off? I know that you physically paid 73,000 Rand, but how has the loan been decreased? So I have paid off 162,000, take away the fact that the loan is now 118,000 Rand. So what's that difference? What have I effectively paid off for my loan? So effectively, my loan has gone down by 43,179 Rand and 93 cents. That's how much my loan has decreased by. But hang on, wait one moment. If my loan's only gone down by 43,000 Rand, but I've actually paid 73,000 Rand that I've actually physically paid over, why are these different? And those are different because not only have you paid off the capital, so we call it the capital, so the original 162,000 Rand, that's the capital. You have decreased that capital by 43,000 Rand by paying 73,000 Rand. And that difference is all the interest you've paid off. So my interest is the fact that 73,000 Rand and 12 Rand and 56 cents subtract the fact that you have actually only paid off 43,000 Rand. And so this is roughly about 30,000 Rand. So I get just less than 30, so I get 29,832 Rand and 63 cents, which is quite interesting when you actually work out how much interest you've been charged over the time. So that's a very popular question because it's quite weird to get your head around the idea that, yes, I've physically paid 73,000 Rand, but not all of that has gone towards reducing the capital, the original loan. Part of that has gone towards interest. And if you just look at your loan versus the balance, you can see how much the capital has been decreased by. So the other portion is all the interest. Okay, let's do 2 more examples. This question says Ashley takes out a loan for 250,000, repays it monthly, so it's an annuity, with 18,000 Rand. Interest is added at 10% per annum, compounded annually. Now that's not good. This is the first time we've had this example. I can't possibly work with an annual interest rate if I'm paying monthly. So this is not good. These do not match, and I have to use, in my formula, I have to use an interest rate that adds on monthly, because it adds on a month worth of interest and then it takes away an X. So this is fairly mean to give you a question where they don't match. So my first port of call is I need to convert this to a nominal interest rate compounded monthly. So that's bringing in our grade 11 stuff. So before I even look at how many monthly repayments, I first need to say, right, if I have 10% per annum compounded annually, so that's once a year, how do I convert that to an interest rate compounded 12 times a year? So that'll be 12 times because this is 1 year. Okay, so don't forget that this is 1.1 and I'm going to 12th root it so that I can get rid of that exponent of 12. Then I will take away this. From here, I generally just work on my calculator because I get tired of writing all these decimals. So I take away that 1, then I multiply by 12, and then multiply by 100. So I land up getting an interest rate of 9, now I shouldn't really round this off. So it becomes a bit annoying in a calculation like this. So let me just keep a whole bunch. I get 9,568,968,515% compounded monthly. Now I can do this question. So it says how many monthly repayments of 18,000 Rand are needed to repay the loan. Right, so my loan is 250,000. This is a present value annuity, 250,000. My X value is 18,000. I'm going to do 1 minus, and to be honest, I would probably keep this on my calculator as my answer button, just because it'll make my life easier. Blah, blah, blah. Divided by monthly to the power of, and monthly installments over how many years? Oh, it would help if I said over how many years. Oh, I don't know that. That's the whole point. Oh gosh. All divided by an interest rate, which is 0.9568, blah, 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 over 12. So hopefully I've done that correctly because I was losing my marbles there. Okay, so I would, this is the difficult solving for N1. And so it's a bit annoying with this horrible decimal. And so I would keep it as an answer button on my calculator. So I'm going to say 250,000 divided by the 18,000 and multiplied by that. And then I'll probably push equals, and so I'll probably lose a little bit of this this answer button ability. Okay, now I'm running out a bit of space, but I get 0,11075 blah blah blah, and that equals 1 minus 1 plus this interest rate divided by 12 to the power of negative n. Now if you remember, I like to swap these rounds, so I bring this side and I take that over there, so I get 1 plus 0,095 divided by 12 to the power of negative n. And 1 minus answer, because you can use your calculator, is 0,88924, blah, blah, blah. Now I'm just going to do some erasing here, unfortunately, because I didn't allow myself enough space. So let me erase that. Okay, now I would probably use the definition of logs. Now don't forget you're solving for negative n now. So I would now say log base 1 plus 0.0, which is going to be annoying because I'm going to have to write down a whole bunch of decimals, divided by 12 of my answer, which is 0,8892, will equal negative n. So use your answer button for that 0.88, and then you only have to put in all the decimals for the interest rate. Now I get negative n, hopefully this is right, negative 14,78 if I round to 2 decimal places, So N is equal to 14.78. So how many monthly repayments of 18,000? There are 14 repayments of 18,000 and then one smaller one. Now I was just thinking, in an exam, I would definitely have asked the first questions to say, please convert 10% compounded annually to a monthly interest rate. And because if you ask that in A, you're allowed to round off, in the next question, you could then use the rounded off version. So in future, I should ask that question first, simply to avoid all these decimals. But unfortunately, decimals make a huge difference. So if you round it off, you probably would have got quite a different answer. Okay, so that was pretty much recapping grade 11 converting and then solving for N. And now there's this question about what is the value of this final payment. Okay, quite a common question and quite a useful one. So basically, I have a loan, and I'm going to make 14 payments of 18,000 Rand. My loan was 250, so here's my loan of 250,000 Rand. And each month I'm going to pay 18,000 Rand, and up until the 14th month, and then in the 15th month, clearly I don't have to make a full payment of 18,000 Rand because there was a decimal answer. Now you can't just say, okay, so it's 0.78 of 18,000 Rand. That it's not how it works. So how does final payment work? Well, the idea is, can I figure out my balance of my loan on the last day that I make a full payment? Because if I can figure out how much I owe then, I can figure out how 1 month later, what would I then owe, because that would be my final payment. So it really is an application of balance of the loan. So let me just say that again. The aim is to say, right, how much money do I still owe? What's my balance of the loan? Always on the last day I make my full payment. Because then if I know my balance of the loan, I can say, right, 1 month from now, what will I owe? So let's practice our balance of our loan again. First step is to pretend the 250,000 Rand simply didn't pay off a single cent, and I'm just going to add on interest for 14 months. Now, because this is a new question, I'm going to use my rounded off interest. So I'm going to use interest at 9.57% compounded monthly, because otherwise we'll be writing decimals forever. So my first step is to say, right, 250,000 Rand, and I'm adding interest at 0.0957 compounded monthly, and I'm going to do 14 months, because remember, it's balance of the loan on the day you make your last full payment. So I get my loan would be an amount of 279,406 Rand, and I'm not going to round this off, 5,994. Okay, so that's how much my loan would have been if I hadn't paid off a single cent. But you did pay off. You paid off a lot. In fact, you paid off 14 payments of 18,000 Rand. So my second step is, what is the worth of all those payments, which is a future value annuity. So I paid 18,000 Rand at an interest rate of 0.0957 divided by 12 for 14 months. Remember 14 because you didn't make that last payment yet. I'm trying to figure out what's their worth on the day you make your last payment. Okay, now I'm not too sure why I wrote 14 here. I think I just had 14 in the head. Now I get that all my payments were worth 265,489 Rand, 0478. Now you'll know if you made some mistake with the N or some mistake with these calculations, simply because the difference between these two can't be bigger than 18,000 Rand, because otherwise you would have made a whole another payment. And so I'm pretty confident this is probably right. So my balance is, I'm going to say, right, my 279,406 Rand that my loan is worth, and let me erase this, I'm going to subtract all the payments that I have effectively paid off, and that difference will be the balance of my loan on the day I make my 14th payment of 18,000 Rand. I think I said payment of 14,000 Rand, I meant 18,000 Rand, and I get that I still owe 13,917 Rand and 55158. Now I haven't rounded those off because what happens, that's how much I owe on the day I make my 14th payment. But unless I come into some money on that same day and then decide to pay off my loan on that same day, I'm going to have to wait an entire month before I make my last payment. Now, that money basically sits in the account, you owing it for an entire month. Now, what does money do when it sits there in an account? It gains interest. So in my fourth step is I now need to add on 1 month's interest to this payment. To this balance. So basically, last payment is really balance of the loan, but then just an extra step because you have to say, I owe 13,917 Rand and all of these funny senses, but I must add on interest for 1 month because 1 month later I will pay that amount. And so I get a final payment of 14,028 Rand and 54 cents. Now again, you'll know if you're incorrect because if you get an amount bigger than 18,000 Rand, you're definitely wrong. And also 14,000 sounds about plausible because if I look at N had a value of 17.78. Now while you can't just say, okay, so it's 78% of 18,000, it doesn't work like that. It does mean that you are almost at another payment. And so it must be a fairly high amount. If you only got a balance of 1,000 Rand, then you'll definitely know you made a mistake. Okay, so this really was a balance of the loan type question, just with an extra step added on the end. Okay, now the question here, again, interesting question. How much interest did Ashley pay in total when repaying the loan? Okay, well, let's look at how much did Ashley actually pay. So she paid 18,000 Rand 14 times, and then 14,028 Rand and 54 cents. So that's give me a total paid of 266,028 Rand and 54 cents. Okay, now what was she meant to be paying off? Her loan originally was 250,000 Rand, if I remember. And so effectively she's paid 250,000 Rand of a loan. But she hasn't because she's paid 266,000 Rand. And so that difference between what she's actually paid and the capital that got paid off is interest. So her interest is 16,028 Rand and 54 cents because it's the difference between the loan amount and what she actually paid off on the car. Now that seems like a very small amount of interest, and it is, but don't forget this was interest of 10% per annum, so 9.57% compounded monthly, but there was only 14 payments, so that's only just over a year, and so it makes sense that the interest rate, the interest amount would be something fairly small. Okay, let's look at our third example. Joe takes out a loan of 100,000 Rand and is repaid it semi-annually, 3,000 Rand, so that means twice a year. Interest is at 12% per annum compounded semi-annually, thank goodness. 3 years after the loan was taken out, Joe wins the lottery and wants to pay off the balance of the loan immediately after the 6th payment. What amount must he pay to pay off the loan? Okay, so this is a perfect balance of the loan type question. Joe's loan is 100,000 Rand in the beginning. Joe is going to make semi-annual payments of 3,000 Rand. So after 6 months, she will pay 3,000 Rand and keep on doing that until after 3 years. Okay, so now we have to be quite careful. There's 2 payments per year if they're half yearly. So 3 years would be 6 semi-annual payments. Oh wait, they even told me that. How generous. So basically, what is my loan there? Excellent. This should be a nice kind of recap for us. First step, let's pretend that my 100,000 Rand, nothing happened to it except it gained interest. So 100,000 Rand gained interest at 12% compounded semi-annually for 6 time periods. So that would be an amount of 141,851,9112. So that's my first step. My second step is to say, but hang on, I paid all of these 3,000 Rand installments. So what is the future value annuity of all my installments? So X is 3,000. My interest rate is 12% compounded semi-annually. I made 6 payments, and this was immediately after my 6th payment, which is what my formula does. So that means my payments are worth 20,925 Rand 95561, which seems about right because you only paid 3,000 Rand 6 times, so it isn't an exorbitant amount of money. Right, so my third step is what's my balance. My balance is how much my loan is worth. So step number 1, I'm too lazy to write it out, subtract step number 2, which is quite a huge balance here. And so my balance of my loan is 120,925 Rand and 96 cents, which means my balance of my loan is actually increasing. Now, if your balance of your loan is increasing, it pretty much means you will never pay off this loan. So if you try to solve for N here, as in if 3,000 Rand Joe was paying it off, how many semi-annual payments must she make? You would get an error, because the reality is she's never going to pay off her loan. 3,000 Rand is not even covering the monthly or semi-annual interest on 100,000 Rand. Fortunately, she won the lotto, or yes, she did win the lotto, and so what must she pay in order to pay off the loan? She must pay 120,925 Rand and 96 cents, and then she would have paid off the loan. Great, so let's just quickly look at the idea of a summary of balance of the loan. So, first step with balance of the loan is pretend that you do not pay off a single cent of the loan and find out what that loan is worth on the day you want to know where your balance is. So I've just written that down. Pretend you don't make a single payment. Find out what the loan is worth at the time you want to know the balance. And how do we do that? You simply use your compound interest formula. Okay, but then you say to yourself, hang on, I did make payments. So basically we need to find out the worth of all the payments you made, which is a future value annuity. So I've just written that out, exactly what I've said. And now my third step is basically my balance is equal to 1 take away 2. So how much was your loan worth, take away how much your payments are worth. And that's pretty much balance of the loan. Remember, a memo might look very different to this because there are probably around 5-6 ways to do this. Okay, so how do I do my final payment? My final payment is pretty much these 3 steps, because the final payment involves finding the balance of the loan on the day you made your last full payment, but then you add on 1 month's interest to that balance. So basically just written that there. Final payment, balance of the loan on the day you make your last full payment, and add on 1 month's interest to that. And the only other thing which popped up in this video, which I'm so glad it did, is that your interest rate compounding period must always match your payment time period. And so if they don't, you first need to do a little conversion. But in reality, in an assessment, if that did happen, they probably would ask you that as a, first starting question, can you do the conversion? But that's just why you're doing that conversion. Great, so that's the end of financial maths.